LeetCode problem number 46, permutations. So this problem gives us a list, an array of nums, distinct integers, and we have to return all the possible permutations. Very straightforward problem. So the way I did it is to use backtracking, and in my backtracking function called recurse, I have to use a recursion which keeps track of nums, which is the vector we're keeping track of, and n, which n will mean that which number we are at the recursion. So when the recursion is first called, n is equals to 0. So this if statement will only trigger if n is equals to 3, right? The num size. So since that did not trigger, so we enter this while loop. For I is equals to n, I equals to 0. We swap, right? We swap both of these numbers, which are the same, so we don't need to do anything here, and we recurse, right? So we recurse, n is now equals to 1. This is in the for loop. So here I is equals to 1 as well. We swap, nothing happens, n equals to 2, I is equals to 2, and we swap again, n is equals to 2, 3, sorry, okay, here, when n is equal to 3, this if statement is triggered, so we push back nums. In this case, nums is just 1, 2, 3, so on our result, we will have 1, 2, 3 inside. When this is done, our I will increment to 3, and when that happens, we will then need to swap. Before that, when we exit the recursion function here, we will need to swap back. But since both of these are the same, so we don't need to do anything, but just keep in mind. So since we don't have to do anything, so we swap I and n, so I is incremented to 3. And when that happens, since I is no longer less than num size, it will just exit. Right. Just exit here. Okay, now that we're here, at where n was here, 0, 1, so now I has incremented. Same thing as before just now, since we exited in this recursion, we would have need to swap back, but since both of these are the same, we don't need to swap back. And then, so now I incremented to 2, so we need to swap 1 with 2, and then recurse with m plus 1, 2, I is equals to 2. Okay. For I equals to 2, we need to swap the same number again, basically doing nothing. So when n has incremented one more time, n plus 1 is 3. Here, since n has reached 3, we push this back. After that, we exit this, and here we have to swap back, right? This is 3, this is 2. Okay, when we swap back, I increments one more time, so now we reach 3. And since there's no 3, this for loop ends. Basically, we exit here, and now I increments 1 here. So when it increments 1, we swap the first two number. So right now it's 2 and 1. And then we enter another recursion. So n is now 1. So is I. Enter another recursion. N is now 2. So is I. And when that happens, enter another recursion. N is 3. When that happens, we push back nums, push this back, exit this becomes 3, there's no 3 in this for loop, exit, and now I becomes 2. When this happens, we swap 1 and 2, so we get yeah, so we get 1, and then we recurse again, n equals to 2, I equals to 2, and here n equals to 3, so we push back, push this back, exit this, swap back, 1, 3, swap back over here, and then increment our I again to 3. But since there's no 3 in I, there's no 3 in num size, so we exit here, swap back once again. So we're back to where we started from, but this time we increment I one more time to 2, recurse, n equals to 2, or n equals to 3, and when this happens, um, sorry, I equals to 2, we have to swap, to swap 0 and 2 first. So 3 and 1. Okay. After swapping, we recurse again. So now n is equals to 1, I is equals to 1. Do nothing, n equals to 2, I equals to 2, do nothing, n equals to 3, we push back, push this one back. Okay, so this will exit, this will swap back and exit, and since now I can be incremented to 2, so here we are swapping 1 and 2, so 1, 2, once we're done with that, increment again, I equals to 2, 2, and equals to 3. When this happens, we just push this back. Okay, once that is done, this one exit, swap back and exit, swap back, so 3, 2, 1, and exit, and we increment I again, this for loop will exit, and then we will return our result, which is this, right? You can see if we look at our list here, 1, 2, 3, 1, 3, 2, 1, 3, 2, 1, 3, 1, 3, 2, 3, 1, 2, 3, 1, and then 3, 1, 2, over here, 3, 1, 2, and 3, 2, 1. Okay, so you can see this function works. Again, this is a straightforward problem, so my solution to it is pretty straightforward as well. Hopefully my explanation is clear. That's all I have to show. Thanks.